Join me on a fascinating journey where I show you some of the techniques used in scale aeromodelling. Hello gang, welcome back to the channel. It's been a bit of a while. I've been off doing all sorts of other things and the channel has suffered a little bit. I'm sorry about that. This is my Pa23 150 Piper Apache with the vertical tail, which is slightly unusual. Everybody remembers the slipback one. But this is the vertical tail version that I drew with the help from a friend in Holland. Back in 2007, I think it was, that I started drawing this. So it was all done in CAD, in 2D, and then my friend in Holland, Tom, he took the 2D drawing and added a third dimension to it so that we could see if the shapes of the nacelles and the fuselage were correct. In CAD you can put a skin on your drawing and you can see then quite clearly whether or not it's true. And Tom made a few tweaks in here and there just to get it to sit right, and extrapolated some formulas from the drawings. And this is the result. The parts were all cut by Rob Bulk of RBC Models, so thank you, Rob. And we will get there and we will have a flying model that you can then maybe market, so we'll see. So if you want to follow along, what I'm going to do, this model is ready to fly. Believe it or not, it is glassed and it is actually ready to fly. And I was going to fly it in this state just to make sure everything was good. However, a bit of a change of plan. It's not quite large enough. It's 1/6 scale, but it's not quite large enough for RC to be competitive RC, which is why it sort of got put on the back shelf. So what I'm going to do is I'm going to convert it to control line. And I'll show you how I'm going to do it. Now there's a major problem with this one because I can't get in to do the bell crank without really hacking the cockpit apart. And I'm trying to decide whether to go in from the bottom and open it all up underneath where it might be less damage, or whether to cut the cockpit top off, get in, do the bell crank adjustments and then put it all back together again. What I'd really like to do, if I can do it, is make it like my other control line scale models, and that is where there's a link between the bell crank and a servo. And if I disconnect that link, then the model can be flying control line. And if I enable the link and leave the lines off, I can fly the model RC. Flaps, ailerons, rudder, elevator, all the RC side of it is already done. So that's the ideal way of doing it. And I think to do that sort of level of beefing up inside to put the bell crank, because the bell crank has to be very strongly mounted in this model. I think really, in all honesty, I'm going to have to cut just behind the windscreen and just behind the rear windows and take this whole centre section off with the side windows, which I was never very happy with anyway, so it'd give me a chance to correct those. I think that's how I'm going to do it, and it will allow me to do a little bit more detail work inside the cockpit as well, which I was, you know, it was sport scale, it wasn't really quite accurate scale, and I need to make it a little bit better. So I think, just thinking about it, and I've been doing a lot of thinking about it, I think taking the whole cockpit top off is going to be the answer, which means taking a saw to this thing. So it's quite worrying, quite scary. But as you can see, that's the next little project we're going to look at. If you want to join along, that would be fantastic. If you want to add some comments, again, that would be fantastic. And we'll see if we can get this flying in this bare state, but with the bell crank in the next few weeks. That's the ideal. And so there we go. First of all, one of the things I'm going to show you first is I'm actually going to put a laser level on this so that I can work out where the lines can come in from the wingtips, because they need to come in from the very top of the wingtip, and I need them to clear the nacelle just, and then to the fuselage. So I then need to work out exactly where inside of the fuselage this bell crank's going to have to sit. Ideally it should be low down, but I can't do that because the nacelles are in the way. So we're going to have to compromise and see what we can do. So without further ado, let's go and look at some of the internal structure of this model before we start cutting it apart, just to see what I built into it. You can see the basic structure in CAD. All interlocks. Fuselage is built upside down with a sort of a central spine, horizontal spine, and then it's flipped over and you can put the top section together. You can see the area where the bell crank is going to go. It's just above the wing tongues and just above the servos. The servo on the bottom is the elevator servo, and that's the one we've got to intercept. And there it is, all pieced together. Magic, isn't it? So as we can see, it's doable. The angles will work. So what I'm going to do is I'm going to take the canopy, the windscreen off, because I do need to get in there and add a little bit more detail. So I can make another canopy if this one gets damaged, but it would be nice if it'll come off without breaking too much. It's just hanging on in a few places. I'm going to go and get something soft that I can slide under. A little wooden coffee stirrer might do it. I've got a large one and a small one. Let's try a larger one first. Well, it's certainly well attached. If I remember rightly, I've actually put a layer of glass cloth over the joint, so that's probably what's cracking and making it so difficult. Okay, that's all the way around the bottom. Just got to come across the top now, if we can get it to go. Oops. No damage, it just popped out. There we go. And there's the pilot figure. Long time no see. There he is. So we'll cut this off just here, and then we'll take all this out. It's a shame the inside is all nice and black and everything else, but it doesn't matter. It'll all come good in the end. All right. So the next stage is to make a cut along here, and then we'll go a cut along the back as well. And it's going to make a mess, but it's all going to be worth it in the end. And that's the windows removed. There's been a bit of damage around the edge, but I was kind of expecting that, so we'll redo this whole section. But what I need to do now is work out where the bulkhead is and cut just this side of the bulkhead right across the top and across the top of there, so that we've got full access to where the bell crank is going to go. We'll have to take the seats out and the base and that sort of stuff out, but that can all be remade. This floor and the rear bulkhead is made of Depron, so I can just cut some more pieces. I'll try and get those out, not necessarily intact, but I'll get them out and I'll be able to use them as a pattern to replace it. It's F4H, so the cockpit doesn't need fully detailing on these models. It's judged from 5 meters, so you don't need to put too much in there. Right, so the next bit is to cut right across the top here. Now, do I want to take these out at the bottom or at the top? Take them out at the bottom. Now there is actually a false bulkhead there, so I'm going to try and take them out at that. There we go. And there we have the cockpit area. And the saw did manage to damage the Depron at the back there, a bit of a shame. But not to worry, that'll probably just I'll just probably overpaint that. But you can see how I did the seats. They're made from foam. They're just sculpted, and then pilot figure. I'm hoping that this top section will be able to do the repairs and actually just refit it, because it is already glassed and ready to go, and it's the right sort of shape. Just needs a bit of trimming down. Anyway, that's the plan. So, cleaning up the edges, let's just see if we can get all this out. This is going to get damaged, so I'm not too worried about it. The seats and what have you probably held in with U-hoop pour, which would be my usual. Yep. Actually, they are painted. But it is poor, I can tell by the discoloration. But they've held reasonably well when you consider this. These were glued in many years ago. Pilot figure, which you hadn't seen before, was one that was done for me by Dave Banks. And it doesn't want to come out easily. Nice, isn't he? So that's one of Dave Banks's pilot figures. And this one. That's that out as well. Now you can see the area that we've got to work with. And I had thought it was slightly further forward than that, but it isn't. So I've misinterpreted the drawings, which is a bit of a shame, because looking at that I probably could have gone in through the underneath. But not to worry. Don't think it'll be too big a problem. So what we need to do is put a bell crank about here. So I might remove that stringer there, and because I think the actual centre of gravity is about here. So the forward lead out is on the COG. So we could put the bell crank between those two. It might just be enough. But yes, might just be enough if it's between those two. But I think for safety, I might need to take this centre one out and drop it down in there. But we'll see. We'll see. All right, so quite a bit of thinking to do now. And there's actually cobwebs in there. That's ominous, isn't it? But there's the elevator line that we need to tap into. So we need to connect to that elevator line with the bell crank. So what I'm thinking of doing is a tower with an arm at the bottom and the bell crank at the top, and then the tower is rigidly mounted within this structure here. So that's the plan. Well, it's been very slow going, and most of it is because I'm thinking, and that's always dangerous. But the big problem is the lines come in about here, well, around here, and they're about 30 millimeters up from this sort of center plane. So the bell crank's got to be up above this platform, which is one problem. The next problem is the push rod, which is actually a Bowden snake, is 50 millimeters down. So I've got a distance of about 85 millimeters between the bell crank and the push rod. And that's a bit unusual. I've not had that problem before. And if we were building this for control line, I would simply put the bell crank here on a platform, and that push rod wouldn't be a snake, it would be a push rod, and the push rod would be up here going straight back to the elevator. And it can do it. The route I can see all the way to the back, and it would work. However, I'd have to cut the tail open completely to get in there to unclip the clevis and fit a push rod. So I don't really want to rip the whole tail apart. It's bad enough what I'm doing here, ripping all this apart. So what I've come up with is, I think, quite cunning, but we'll see what you think. So I've taken a piece of machine steel, and even that was a little bit fraught because it was actually 4.05 millimeters, and these little bearings that I've threaded on needed the internal diameter was exactly 4. So I've had to grind this down on the lathe. So I put it into the lathe, and then I used a file to just file it down, and it took ages. I couldn't think of another way of doing it. I tried actually holding this end and using the tool on it, but it just moves too much and you can't get an accurate cut. Anyway, it's worked. So there are 3 bit, and that one's temporarily decided it's going to stick to the bottom there. It is free to slide, but anyway, don't worry. There's 3 bearings on that shaft, and I'm going to build a box out of plywood here that sits on this, and I'm going to put some runners, hardwood runners underneath that this box will then screw onto. So I'm transferring all the load to this structure here, all of this lot. So the idea is that this shaft will go down to the bottom there, and I'll cut this push rod, this snake, so that I can put a clevis in there, and then this will operate the push rod. Okay, so there's some plywood structure here that these bearings are going to sit in, and there'll be a bearing at the bottom, bearing in the middle, and a bearing at the top. Okay, and they'll sit in this ply structure, which I'm still working on. And then on top of this, I've made a top hat section on the lathe, and it's just some T6 alloy, and I've threaded it so that it takes a grub screw, and it sits on top, and you'll lock it off. And then on top of that, there are some ply discs, and these are yet to be drilled. So those 3 holes there that you see on the bottom, those 3 holes will take self-tappers, well, not self-tappers, will take threaded screws down from the top. Then we've got this bit here. That's upside down. I need to mark that more clearly so I can tell straight away. I can see when it's the wrong way up. But, and then we've got this last one as well. So the idea is, you're probably familiar with the bell crank that is a T. 2 longer arms and a little arm that goes to the push rod. Well, because we've not got the push rod coming off it like that, all I need is the 2 arms really. But there is a nicer way of doing it, and that's to use a circle rather than 2 arms. And what this allows, I'll turn it round. Well, that's actually the way round it'll be in the model. So what happens is the lead outs come in, go round this, go into that little dimple area, and there's a screw goes through there that just traps the wire, and then it goes back round and it comes out here. And the idea is, as you push and pull on the lines, this turns, which turns the whole shaft, which moves the push rod. Okay, but the good thing about using a circular push rod, if you used a T-bar, as you pulled it, it would move in, and that puts wear on the outlets that are coming out here. This way is far more smooth and everything stays at the same angle as it operates. So the line goes through there, and then this piece simply goes on top. And that's all glued together as a sandwich, and you'll see there's a little groove inside there where it works. And there'll be a hole through here in line with that notch to trap the control cable. Then these cables go out through an exit here, out to the lead out in the wingtip. So that's the plan so far. I thought I'd just whet your interest by showing you what I'm doing. And then this all will get mounted. I don't quite know how yet. With some plywood. I'm building a plywood box effectively that this sits in and is really rigid, and then that box is then screwed down to this section of the aircraft. The problem is we have to do a pull test, and you have to basically weigh the aircraft, and then you have to times the weight by 5, and that is the amount of pull that is exerted on the lines as a test to make sure the structure's safe. And if you don't pass that pull test, then that's it, you're not allowed to fly. You are allowed to hold the model like that while they're pulling that way, so you can spread the load a little bit, but it's still a very frightening part of competition control line. So and it is actually a safety issue as well, that you do this pull test before every flight, even if you're not in competition, just to make sure that everything is solid, because the last thing you want is for your model to come off the lines. Anyway, there you go. So that's what's happening. I'll keep this video short so that I can maybe keep your interest, and I'll make this box, and then I'll show you the box once it's all assembled and how it all fits inside there. I am quite worried about how I'm going to be able to actually cut that and get down in here, because as you can see it's very tight, there's not much room, and I've got to cut that and actually thread some rod into the yellow inner, Bowden inner, and then put a clevis on it, and all in a very tight space. So I'm not sure how well that's going to work, but anyway, I'll do that and then I'll report back to you in the next video. All right. Anyway, I hope you enjoy the Apache series, and I'll see you on the next one.